Hello and welcome to the 10th and final video of lesson 1, where we will be talking about the energy intensity method and its also sub-methods. This is arguably the most used analysis method for analyzing demand in LEAP, so it's quite important. So in this video, we're going to talk about the basics of the energy intensity method, and I put method in brackets because it is just really one method, but there are different ways of doing it, and we will be looking at all of them. So we will be looking at energy intensity in a single technology. We will be looking at energy intensity in a folder, or what they call an energy intensity category in LEAP, which can share technologies. And then we're going to use the third method, which is useful energy intensity method. We will also look at when to use these different methods along the way. I also made a separate video with an example of me actually building these three methods in a mining sector really quickly, and you can see that in a separate video, but more on that later. So, energy intensity method, if you haven't remember from the former videos, it has a total of 2 parameters in the standard method, where the total energy has 1 parameter. There is actually a third parameter, but that's only for useful energy intensity methods, and that's efficiency. So for the energy intensity method, we have the activity parameter, which is the service that you're trying to comply. That could be something like the heating of a household, maybe in square meters of area need to heat. It could be tons of production that you're trying to fulfill, that you need to produce, and so on. And that's generally how we define activity. It can be quite free. You define that yourself, depending totally where you are in your model. Then the intensity parameter refers to the activity parameter. So that could be the gigajoule, or let's say for heating, we can say yearly kilowatt hours per our defined activity parameter. So in this case, square meters. So that would be kilowatts to heat a square meter per year, and then we can work from that. And the same thing with the tons. That could also be gigajoule of producing a ton of the product that we need. So that's how the intensity is defined. They will make maybe a little more sense when I look into the LEAP model. For the useful energy intensity method, we also have the efficiency parameter. There we can also say, like, well, that's our basic intensity, but then we also have different technologies that could provide those, and they might have different efficiency parameters, and there could be multiple of these that we can change in between. So that's what that's used for, and now we'll start showcasing that now. So the simplest form, technology with energy intensity, that is the energy consumption is equal to the activity. In this example, it's households, times the energy intensity, which is gigajoules per household, for instance, for heating, for cooling, for cooking, etc. So in this little example, you can see I have my 2 parameters. I have activity level, and then I have my final energy intensity. And then in this case, I define my my activity, which I mean here, as in my base value of 100, and then I have a progression for that, and that is defined as households. So here I can say it might be a number of households, and here I will use my final energy intensity to be what do I need to do to service, how much energy do I have to service this per household, and then we can multiply these and get the energy consumption. Then we also have the category with energy intensity. And as you can see from the logo, it actually looks like a folder, and that's because it replaces the normal category or a normal category in Leap where we use that in branches. The reason for that is because we can have multiple things below this or underneath this. There are two methods when we're using this with the energy intensity category or folder. We can both use the final energy intensity method, and we can also use the useful energy intensity method. The useful energy intensity has to use this green category or energy intensity category because you are describing multiple competing technologies for the same service. And that's important. Well, the same process is also written. So here we have one that is a final energy intensity with the green folder, which is here we have commercial heating or commercial building heating as an example. As you can see in this example, we just have the activity level, and we also have final energy intensity, and then we have fuel share. And this is because we have multiple technologies, or we have the category allows for multiple technologies. So therefore, we have to define the fuel share between them. So here I took on all variables, so we can see both. So this is for specifically for the heating folder. You can see I just specified some kind of activity, and then I specified a final energy intensity. What's to be noted is that all the technologies share the same energy intensity. So it does not differ between maybe the efficiencies or methodologies of the different technologies used. This is quite realistic for how statistics are usually set up. But further on, you might want to use useful, and we'll come back to that in the next slides. But you can see here in this case, I said that my natural gas is just remainder of 100 because then something might, that's the automatic change to make sure that everything is okay. And here I just had electricity and residual fuel oil be a 50-50 fuel share. So half of my households are fueled by residual fuel oil and the other half by electricity. And we just have an average final energy intensity for these. Now, when you are making this green category by using the add button, you get to name it and you get to say like this is the category with energy intensity. You can tick on this box marked in yellow with useful energy analysis. If you put that on, you'll then have individual efficiencies for your technologies. But otherwise than that, it will be more or less the same as the general final energy intensity analysis. You can also see that below this, you have final energy intensities in current accounts. If you take that on, there will actually be a difference in the scenarios. So all prediction scenarios will use useful energy analysis, and the current account scenario will use final energy intensities in current accounts. And that's because quite often in the statistics you're working with, you can maybe see the energy consumption and how much of the energy consumption was in the different fuels, but nothing else. So you may have no quite good a sense of what the average efficiency is for the number of households who use residual fuel oil, because some of the furnaces might be very, very old and low efficiency, and some of them might be brand new and high efficiency. So in this case, it might be better just to stick with the final energy intensity for the past, because they are just lumped together in statistics. So this method for ticking this box allows for that, which is quite good. So it is the same thing with useful energy intensity, just has the same energy intensity specified for the process, but with different efficiencies to fulfill for the technologies. So how does that look like? So here we have the same thing, but where we have tagged on the useful energy intensity. And you can see here in my variables, we now have activity level, and now we have efficiency 2 and useful energy intensity. So instead of final, it's now useful, and we have efficiency tagged on. So for our, this is just for the general heating. So now you can see we specify the useful energy intensity. I started out with 0.17 in this case, and I had a general improvement of or a general negative growth of 1%. This could be if it's heating. That means on average, I'm gonna add more insulation in a good, nice pace, and that will have an impact in the future. And then in the activity here, I'm just gonna have that stay the same. Now, for the efficiency, we have to go and look for the in the individual technologies, and we can go look at these. And as you can see here, we no longer have a fuel share because we are defining the different relationship differently now. So we actually also have an activity level for each of these technologies, which I didn't quite show, but it looks the same as here. So now I get to say like how much of my heating was done by how many of my households were done by these different technologies, and each of these technologies, what is their nominal efficiency, energy efficiency for these. And that means it can vary quite a bit if you have if you change from one technology to the other, because the efficiency might be rapidly different between the two. So just to reiterate, like this is the same as the chart as we had before, or the same slide as we had before, that now we have this example of a house that uses energy based on its area. So that means the energy that it uses is base. That's again the energy intensity, and the area in this case is the activity. So I hope that makes a little more sense now. And then for the useful energy intensity, we have the same situation, but then we both have the energy that it uses, again, which is the energy intensity, the area, which is still the activity, and now we also have its technology, which now defines the technology efficiency, which can be changed depending on which technology is used. So I also made an example for this energy intensity. I didn't put it into this video because the example itself is around 22 minutes, but it does cover the basis of you making both energy intensity and also useful energy intensity, and it is very much live and hasn't really been edited much, so you can also see when I make big mistakes, which does happen, and that is completely natural in a software like Leap. The file is called energy intensity method.mp4, and it's in the same folder as you found this video. So that's where I would look for it. I think it is very useful for looking at that to if you want to make some of the exercises. So this was the end of the formal lesson 1. So I will see you in lesson 2.